an inkling about. Okay, but just in case you don't, this is, now for Unit 5, there will be a few questions on your final exam about this stuff. All right. And you're going to see that I actually kind of have a mixture of figures from Shipman, and before the sheer Shipman text, I actually used I kind of like that. I actually used a book by Tillerman, so there's some different figures. This looks like Frankenstein, right? Okay, so if you're already kind of familiar about it, we'll be talking more about it. So the words are cycles and surface, interior. The stitching here actually are major plates. Some of you guys are already very familiar with that, and we're going to kind of talk about that. But it's amazing how the Earth's crust is actually kind of a recycled sort of deal. The crust goes down and it comes back up again. So it's just recycled. This actually reminded me of astronomy. Okay, we said that our sun turned on about 4.6 billion years ago, and that's about the time, or that would have been then when our planet had all the material it was going to have. Well, plus or minus, most of the material it's going to have. Okay, then it started solidifying. Okay, it actually started out very ooey gooey. Okay, so the surface cooled. We're going to talk about different rocks, and they have cool names. Okay, so igneous rocks are one of the, I think, 3 types of rocks. But at Earth's surface are these type of rocks, these igneous rocks. Now, the interior of our Earth is actually still warm, but it's not, it's cooling down. Okay? The warmth that it had here that's talking about, the warmth that it still has, actually is related to matter going through radioactive decay. And I didn't talk about nuclear chemistry, but radioactive decay is basically when an element transmutates. I don't know if that's the word I want to say, but it basically, an element over here that's heavier, it breaks apart, loses a proton, converts some of the subatomic particles, and becomes something lighter. Radioactive decay, and it releases energy. So that second melting occurred in little pockets throughout the interior. Okay. So our planet, as its crust solidified, kind of think of it this way, or even maybe before its crust solidified, it started this differentiation process. It's called planetary differentiation. And it reminds me of Italian salad dressing, basically, where heavier things sank and lighter things rose. So right now, in the Earth's core, mostly iron. And as you might imagine, and there's all sorts of science fiction movies that talk about there's dinosaurs in the middle of the Earth. No. It's an interesting thought. But no. In the interior of our Earth, you're looking at very high pressures and very high temperatures. Okay, the Earth's center. Interesting thought, though. All right, so I have some videos to kind of reinforce this, but the 3 main zones, we actually, and there's kind of subzones of these, but we have the outer crust, and then after the crust we have the mantle, and then going towards the center, then we have the Earth's core. This is kind of the simplest way to look at 3 main, see, I don't even say layers, because there's layers within these 3 main zones. So let's take a look at this video. Let's see what we think.